Hello, Algebra students. Today we are continuing our Unit 5 content by looking at Lesson 13. This is a continuation of reasoning with exponential functions. So we are going to take a look at a scenario involving the value of a computer. So we have a graph representing an exponential function. We have the function of f gives the value of a computer in dollars as a function of time measured in years since the purchase of that computer. So based on the graph, what we are going to do is answer some questions. So I really want to take some time here to look at the purchase price of the computer, to find the value of f when x is 1, what f of 1 means, how the value of the computer is changing each year, and then to write an equation that defines f. Then we will use that equation to determine how close we can determine the value of that computer when our x is 10 years. Okay, so what I'm going to do first is look at the table of values. I'm going to pull that out. So we have our x and our f of x. Here we have 0, 400. We don't have our 1 here. That's not listed as an ordered pair. We also don't have the 3. However, we do have an ordered pair for year 2, and we do have an ordered pair for year 4. So let's see if we can determine then our purchase price of the computer. That is another way of asking for our starting value. Our starting value is 400. In year 0, that's the moment we buy the computer. Okay, so let me scroll up here. Okay, get rid of these marks. So if this is 400, 2 years later we're at 100. We know this is an exponential function. So can I figure out what this should be in year 1? If you notice, we have a gap between our 400 and the 100. So how many times do we use our multiplier here? So we go from 400 to a space to a 100. And in that process, we multiply by our b value, and then we multiply by our b value again. So to get from 400 to 100, we are multiplying by what we call our decay factor twice. And repeated multiplication, remember, we list as exponents. So here I'm doing 400 times b to get 100. So 400 times b squared equals 100. So we can go back to our equation solving skills we learned first semester to get this b squared by itself. I'm going to divide both sides by 400. That gives me b squared equals 1/4. Okay, b squared equals 1/4. How do we undo squaring? I think we've talked about that before too. The opposite of squaring, or the inverse operation of squaring, is square rooting. So what I'm going to do is square root both sides. So the square root of b squared, so what number times itself is b squared? Well, b times b is b squared. What number times itself is 1/4? Now you can use a calculator to do this if you want to. Let me find my calculator app. Okay, there's my calculator. And I'm going to do the square root of 1/4. That's 0.25. Ah, I see. It's going to make me do the 0.25 first. Let's clear all. So 0.25 and then square root gives me 0.5. That's the same thing as 1/2. If you want to do this using the fraction, you can do 1 divided by 4 to get your answer, then hit the square root. Okay? On your calculator, you can change you can change your answer to a fraction, I think with second table on our calculators at school. So this is 0.5 or 1/2. Okay, so I'm going to write that down. Oh, helps if I'm in the right tool. So 1/2. So our multiplier is 1/2. So if I take that 400 times 1/2, that gives me 200. 400 times 0.5. So the value of f when x is 1 is 200. I'm going to put that in my table. The meaning of f of 1 is the output when x equals 1. So this is the output, or the cost of the computer when x equals 1. How does the value of the computer change each year? That's our multiplier. Okay. Our multiplier is that 1/2. And then our equation, f of x equals our starting value times our multiplier to the power of x. We said our starting value was 400. Our multiplier is 1/2. So this is our equation. F of x equals 400 times 1/2 to the power of x. Part F is asking, what if x equals 10? What is the output when x equals 10? So we are going to take our function, f of 10 equals 400 times 1/2 to the power of 10. So I'm going to come back to my calculator app, or you can go to Desmos Scientific Calculator, which might be better. Highly recommend this, by the way. So I'm going to do in parentheses 1 divided by 2 to the power of, oh, not there, I want it out here. The power of 10. And then do that answer times 400. And that gives me 39 cents. So let's go take a look at this. So our output here is 0.39, 39 cents. So after 10 years, that computer has a value of 39 cents. Does the value reach 0? Well, if we're rounding, I suppose you could say that is pretty darn close to 0. Or you could argue semantics and say, well, 39 cents is more than 0. Would you sell a computer for 39 cents? I will leave that decision to you. So I'm going to go ahead and delete this information. You can always back up the video if you need to see that again. And we're going to look at part 2 down here, which is looking at some graphs. So we have the graphs of 2 exponential functions. We are going to write the equation for each of the functions, and then find the value when x equals 5. So for part A, we're going to look at our function f of x equals the starting value times the multiplier to the power of x. Well, our starting value is going to be on the y-axis. Okay, so we've got our 5. And then we can determine how we get from 5 to 15 to 45. What are we multiplying by each time? So our b is going to be a term divided by the previous term. And we have 2 different opportunities here to check that. So let's see if we get the same thing or close to the same thing each time. So my term, 15, divided by the previous term, 5, equals 3. If I use the 45 divided by 15, we also get 3. This tells me my growth factor, since we are increasing, is 3. Our starting value is our y-intercept. So 0, 5 tells me that 5 is my starting value. To find the value when x equals 5, let's put this into that Desmos scientific calculator. So I'm going to clear this out, and we are going to do 3 to the power of 5, and then times, actually, I can rewrite this. Our starting value is 5 times the multiplier of 3 to the power of 5, and that gives me 1,215. So we're going to come over here and write that f of 5 equals 1,215. All right, let's see what part B looks like. So again, our function, our equation, is going to take that form, f of x equals our starting value times our multiplier to the power of x. Here we are decreasing, so we will have a decay factor. Our starting value is that 20. It's our y-intercept. And then we're going to check our term divided by the previous term. And we go from -1 to 0, so that's one step. Then we go from 0 to 2, so that there's a step missing in there. Okay, so I am going to check for my b value using 40 divided by 20. Okay, and that gives me 4/2 or 2. So 20 times 2 to the x. If you wanted to do this one, going from 5 to 20, you could do that, but that's going to be b squared because we have this missing value in here that we would do b times b. So you could do 5/20. Oh, and I put 2. What am I doing? A term divided by the previous term would be 20 divided by 40. Okay. 20 divided by 40, 2/4 or 1/2. There we go. So here we have that b squared equals 1/4. So doing what we did before, take the square root, and you still get b equals 1/2. There we go. That makes more sense. Because we are decaying, our multiplier has to be between 0 and 1. All right, so f of 5 equals 20 times 1/2 to the power of 5. Okay, so I'm going to come over here. We're going to do 20 times 1/2 to the power of 5. 0.625. So here f of 5 equals 0.625. If you want to write that as a fraction, you can there is a way to do that. Oh, just click this button right here. And that's 5/8. Okay, so 0.625 is the same as 5/8. So you can represent your answer either way. Both of these are correct. Okay? All right. In this lesson, there are some more opportunities to practice this. The PDFs I know are posted in Google Classroom. We've got some interactive stuff here. We've got a wall covered in mold. That area doubles each month. There's a different mold on another wall and that triples each month. So use that information to match the graphs. And then, yeah, let's look at this. So here we have one function coming up. That's the dotted line. Then we have the solid line that starts lower but comes up much faster. So we know our two molds, one is doubling, so one has a value, a B value of 2. The other, I'm going to say, is subscript of 2. We are tripling, so that's a multiplier of 3. So which one of these increases faster, at a faster rate? Yeah, that's our solid line. And the one that's increasing slightly slower than that, B equals the multiplier of 2, that's our dashed. Okay, so the dashed, or the multiplier of 2, that's mold A. And the multiplier of B is this one, or that's mold B. Okay. Which mold has more present at the beginning? So that means we're going to compare the Y values. So which one starts with more? And that's the one higher on the graph. So mold A starts with more. Okay. Which one is growing faster? Mold B. And what does this point PQ mean? If you may remember from first semester talking about systems of equations and how where those systems, where those graphs cross or intersect is our solution to the system. That's our intersection point. So PQ is the time it takes to have equal areas of mold, which sounds disgusting, but that's another story. All right, so we can use our information to interpret, to compare, to make decisions based on the information we have. I hope this helps.